Hey guys, as I alluded to at the end of the last video, I'm actually pivoting on my personal project side to a much more low-level Vulkan game engine development type situation for virtual reality, specifically for my Valve Index, but maybe other devices at some point. So this is what I currently have here. It's a basic Vulkan renderer, currently just running in a window. I'm very early days in learning Vulkan, so I'm not actually going to get into that today. But what I will be showing you, however, is my setup for building out a C++ engine library in CMake, which is, in my opinion, probably the best choice you can make for build chains or compile chains or whatever you want to call it, because of the general adoption that people have done and the ease of importing libraries. So we'll start from scratch, but I'll just show you roughly what it'll look like. Just a note, I don't know where I'm going to put this in the video yet, but I will be going back to show you some more Godot stuff, specifically the Android in-app purchases, AdMob, and most importantly right now, my priority over the next week or two, I tried to do it last weekend, but there were complications, is to release a new DragonBones binary, which supports Godot 3.3. There was an issue with the Linux builds, and I think there's going to be an issue with the Android builds as well. So I've got to put some time into it, and I didn't have time last weekend to do it right after the release. So look forward to that in the next few weeks. I'm going to try to put my engine development a little bit on the back burner while I read more textbooks and get that new binary out for you. Yeah, so back to the video now. And so you're not going to have all these documents, but you'll see I have a parent directory. Inside there, I have a engine directory, this is my library, and I have the application directory, which is my application, which is actually very simple. It's just a main.cpp, which is actually what's being run. When I hit play on this, it's actually running this main.cpp here. And it just takes a minute because it loads all the models, and it does this. What I'm going to show you today is how to set up this folder structure, and I have this engine directory, which has an include directory, which includes all your public APIs. So you'll see here that I have access to my renderer and my input manager from here. And then you will also have all your private implementation stuff. So you'll see Vulkan is not exposed to the application layer due to the structure that I'm going to show you how to do today. So without further ado, let's get into it. So for the requirements of this video, it's actually going to be really simple to start off with. We're going to use Visual Studio Code as you do. You can also use CLion to do it, but Visual Studio Code is free. So let me create a new window for that. So we're going to use Visual Studio Code to set up our project, where we are going to import a few libraries and show you the difference between private implementations, public implementations, and all of that. So to start off, when you get into Visual Studio, you'll want to make sure to have a few few extensions for development. There may be more, but the main ones you'll want is C++, C++ by Microsoft, the C++ extension pack, and you'll want the CMake tools, which will also install CMake as well, I think. But you'll definitely want CMake tools. So to start your project, what you're going to want to do is create a new folder to contain your project. So we're just going to put it into, let's say, documents, projects, and new. We'll say YouTube project. So this will be our YouTube project. And we'll choose this as a folder. We'll create the folders first, and we'll set up the CMake files afterwards. So we're going to create let's call it app. This will be your application folder. So your main code will be in here. And you're going to create a let's call it engine, and move that to the top level, not within app. Within engine, you're going to want a couple more folders. You're going to want include, and you're going to want source. And that's going to be our entire folder. Oh, and one more. We're also going to want external for external libraries. And one last thing is usually you want a source folder inside your application as well. So create a source folder in there. So you've got app source, engine, external, include, source. Now we'll start making the various, we'll start setting up CMake. The first thing we're going to do is we're going to create our first CMake list file. CMake list.txt inside our app, and not our source, just the app folder, like this. And inside our source folder, we're going to create a main.cpp. We're going to include IOStream, and this is just to prove that everything's working. And I believe it's like int argc, int argv. What is it? Whatever. Car argv, something like that. Anyways, we'll see if it works, and we'll just do the standard hello world. Okay, so we have, this is going to be our main thing that runs. We'll go CMake list inside here, and we will call this here. So first thing we're going to do, we're going to start with CMake minimum required, and it's going to be version, and I've been using 3.5, but generally I use the lowest version that supports all the features I'm trying to use. As we're going to give it a project name, and we're going to call this YouTube CPP application. It's going to be version 001. It's going to be a C++ project, or a C project. Finally, I like living on the bleeding edge, so we're going to set it to be a C++ 20 project. Now, if you don't have a C++ 20 supported compiler, set this to whatever you want, or even remove it completely. It might not be important. So we're going to do things a little bit manually at first, but then we're going to make it a little bit more generic because I'm lazy. So the first thing we're going to do is we're going to create our executable. It's just going to have project name as the executable name. So this will come out as, this will come out as YouTube CPP application.exe or .o or whatever this Linux output is. It will have the file name of this by default. And then we are going to give it its source files. Now, usually I would pass in a list here and be really lazy and inefficient about it, but we're going to be explicit just to show how it works. And we'll source main CPP. And then that is pretty much all we need for the CMake list. So now if we go to here and we go CMake configure, Visual Studio Code with the CMake, when you do the configure, it will ask you which C++ compiler to use. You should know which one you want. I'm just going to use AMD64. There's no CMake list found in the root folder, so let's create that to make it work. So in the root folder, we're going to create one more CMake list file. We can copy paste some of this stuff here. Let's just do this. And then this here is, I would do YouTube CPP development environment. You probably don't even need this project name here, honestly. I just like doing it just to be explicit about stuff in case I do need to reference project name at some point. Again, we'll put the 20 standard, and this one simply we're going to add subdirectory app. So what this will do is it'll actually just, within this project, it will just import the other project. It'll import all of these builds here. So if we do another configure, this is configuration already in progress. Let's try that again after I close everything. There. Could not find module, file, compile 00. What did I do? What did I do? Oh, whoops. Here, you're going to want to put the word version. Sorry about that. And again, version. And then it configured properly. So within Visual Studio Code, as soon as you save this, it will reconfigure your project. So you saw it reconfigured and the build files were written here. And what that did is if you go inside the left, once you have CMake tools installed, you'll have this CMake tab. You're going to see that you have YouTube CPP application here now. You can right click this and set as build target and set as launch target. So now when you go to the bottom here, you can press play, and we should see hello world. So that configured our application. Now what we want to do is build the engine library, right? So we're going to do something very similar to begin with. We're going to create the CMake file for that directory, which is a little bit more complicated than the other one. So we're going to create another new file, CMake list.txt. Now in here, we are going to, once again, just take here, this. We're going to just take this, and once again, take this here, CMake list, and make it and here we'll just change the project name again. We will call it YouTube CPP engine. So with that out of the way, we are going to do a very similar thing to what we did before. So let me see, what do we need to do? First thing we're going to do, which is we're going to create a file here. We're just going to call it engine.h. I'm going to pragma once. Oops. And we are going to create a class, let's say YouTube engine. I think this needs a semicolon. Class YouTube engine. Actually, we'll just say void print hello world. And this will be a pure virtual function. It's not going to be a pure virtual function this time. And this will, I think that's all it needs. Yeah. And in our source, we're going to create a new file in here. We're going to call it engine.cpp. We're going to include, and now this is not going to autofill yet because we haven't filled out the CMake list yet. But I'm just doing this to show you what it's going to look like. And this is going to be right in here. It's actually not, I don't keep it in the first level. We're going to create a new folder here. We're going to say YouTube engine. I don't know if that's naming convention. We'll use snake case, and we'll put engine.h in there. And then here it will be YouTube engine/engine.h. And then we are going to void YouTube engine. What's the name of that? What's the name of that function? Print hello world. Print hello world. And we're going to include IOStream again. SCV count. Hello. Hello, I'm talking to you from the engine library. And we'll add another end line there. Okay, so that should be enough. You'll notice that there's a red squiggle here. Let's ignore that for now. So now that we have a basic setup here, what we're going to do is continue this file. We are going to first, yeah, let's be explicit. Let's do it. Let's be explicit again. Add library. Again, project name, and source engine.cpp. Now, generally you want to list all your source files in here. You don't need to list your include files generally. The next thing you're going to want to do is, one thing that's important when you're building a library are these target include directories. Now these are, you're going to want to set up as project name, and I'll explain to you how this works in a second. You're going to want to do project name, and then you're going to, I always fill out the sections. So we're going to do public and private, and there's also interface. I don't know what interface does. We'll just do public and private because they're easy enough to reason about. We'll also want it's not going to be as important right this second, but we will need it eventually. Target link libraries, and again we can have a public section and a private section. Oh, and again you're going to want the project name here. So the first thing we're going to want to do is we're going to add in the public section. So these are your public headers that you're going to want to allow access to in the application layer. That's how I've been doing it. And again, I'm still relatively new to all this stuff, so if I make a mistake, please let me know in the comments. So the first thing we're going to do is we're going to add the $install interface. Now some of this is and include, and we're also going to want to build interface CMake current source directory /include. From what I understand, the build interface helps with static libraries, so it will put it into wherever it will read it from wherever the build is happening. The install interface reads it from if you do CMake install or make install or whatever, it will install your library to the operating system wherever it is, and it will include it from that location. I think that's roughly it. Yeah, so I think that's it. So let's just assume that's it, and if I'm wrong, then I'm wrong, and we can figure it out later. So with that done, we can, if we reconfigure our project or we rebuild our project, where's build? Let's hit build. It built the U thing there, but now if we look here in engine.cpp, it now can read. Oh, it can't. Why can't it? So let's just finish up wiring it up and see. It should work. I think it should work. So if we go back to our project tree, we have all our CMake files created. In here, what we're going to want to do, add subdirectory, and we are going to add just engine. And what that will do is it will reconfigure the project, and in our CMake, we'll have the CPP engine. So now let's right click the CPP engine and build, and it tries to build engine CPP, and it worked fine. So now if we go back in here, it reads it perfectly. So now everything's wired up, everything's building, and we've got technically a working library. So now if we go into our application, in our CMake list, we're actually able to include this library. Since it's linked through here, we're able to include the library through here. So all we need to do is in here, we are going to add something very simple, link libraries into our project name target, and we are going to, we use this project name library, which is our library name. And we do the same thing for target include directories. Now, you could do the same public-private stuff with the link libraries and all of that as well, but since this is your application layer, generally it's not being imported into other projects, so it shouldn't be too important. But you do need to do private for includes, just because that's the way it enforces a keyword. So with that done, we can build it again, and if it builds, so nothing wrong with the CMake project. So we should be able to now import our engine.h, YouTube engine, into our main.cpp. So what I'm going to do quickly is I'm just going to make this static, so I don't need to make a new function to a new instance of this and that's here. Let's make it a struct to default it to public. Quick tip: difference between class and struct is fairly simple. In class, this defaults to private, and when this is struct, this defaults to public. That's the main difference between the two. Internally, I believe they're pretty much identical. So in here, we should now be able to include, and the reason why we nested it inside YouTube engine was so that we can refer to it like this. We can include that, it sees it fine, and now we should be able to YouTube engine print hello world. Now we should see hello world and print hello world on screen at the same time. Hello world and hello, I'm talking to you from the engine library. So you now officially have two different CMake projects talking to each other, and you can include them like this in any other project. So if we had wanted to, we could have done it like this. So we have our engine library here. We could have done it this way. We could have taken this source directory and put it at the top level here. Let's actually just move this. Remove this CMake list, not this one, so close engine. This CMake list here, this top level one, we could actually, let's just rename it .backup, .back, and then move this to the top level. And instead here, instead of just doing it this way, we could add subdirectory engine. And this should work as well. So now here, if we go back here, you'll see now we only have CPP application and engine. If we hit play, it still works just fine. And just to prove that it's working without this, let's delete that. Delete our backup file. Let's work with this structure here. Now, usually what I would do in this situation is I wouldn't have engine here. This would probably be a external library. So same as here, how I have an external folder, I'd probably create another folder here, not here, at the top level, called external. And we would put our engine inside here because it would probably be imported from a Github repository. And so we have our external engine source, and here we would just do external engine. And once again, this should work just like it was before. So let's say play. And there we go. Now this will compile on any operating system. This is all just standard CMake, C++ stuff. So that's the basics. Let's show you how to import libraries into your engine and make them accessible both to your application and make it private to your engine. So to do this, let me just create a README file, readme.md. I'll create a README file, and to do this, what I'm going to show you is, let's open the preview just so you can see the pretty version. We're going to get YouTube engine. Technically, this is YouTube application plus engine. So what we're going to do is we're going to bring in a couple libraries. We're going to have one private library, which is going to be GLFW, and we're going to have a public library, which is going to be GLM. So these are probably at least GLFW, that's going to be the first thing that you're probably going to want when you create your application. Probably most GL or Vulkan applications these days are going to be recommending GLFW. So the first thing that we're going to want to do is inside here, it's in the wrong folder. So we're in our YouTube project. We're going to want to go into the engine, external /engine. engine. Now in here, what we're going to do is we're going to make this a GitHub repository. Now usually you're going to separate your application layer from your engine layer on your GitHub or wherever you're keeping your source control. So this is going to be its own project, and I'm just doing this now. Really, I'm just doing this now so that we can add submodules. I'm going to take that down for now. What we're going to do now is we are going to go grab our submodules. So what we're going to do is, so we wanted GLM, which is this gchook GLM. Just, oops, oh man, I spent too much time on Mac. But anyways, we grab that, open Visual Studio Code. In your terminal, what you're going to want to do is git submodule add, paste your code, paste the repository, and then what I do is external/glm. And that will go get GLM. What you could also do is you could clone the repository directly into that folder if you don't want to make a, if you want to do it all at once and you don't want to make your own GitHub repository out of it. And then the second thing we're going to want is glfw. Now you could get the binaries of this and link it dynamically, which in that case you'll like install it for Windows anyway. You'll like install it, and then you will have like, I'm just gonna do this quickly because I don't like doing it this way whenever I can. I like grabbing open source projects off the internet and adding them explicitly. But you could do something like find package glm or glfw and required, and that will get your things. It's just telling me that I couldn't find it. But anyways, you do this, glfw required, find package, it's Vulkan required, that kind of thing. And then inside here, you would add, it's usually something like Vulkan libraries or something like that, right? You can find documentation on this. I'm not going to show you how to do that because I don't do that. I think that whenever possible, just build it from source. It gives you access to the source. So if there's a bug, you can fix it, you can change it, you can do whatever you want with it. It's much better this way, in my opinion. So anyways, back to this. Let's grab glfw from GitHub. Grab this, copy that. And again, same thing, git submodule add. We will add this and external/glfw. So now, if you look inside your engine directory, in your external, you'll have glfw and glm here. So here we've said that our private one is going to be glfw. So we'll go into CMake lists. Let's make this here. And that's what these public and private things are. So the first thing we need to do is import the libraries. Add external libraries. Now, this is why I use CMake. The main benefit to using CMake is that most C++ and a lot of C applications, they will have a CMake list included. So you'll see there's a CMake list here, and there's a CMake list here. Anytime you see a CMake list in a repository, you can add it to your project almost exactly like this. There are ways to do, I can show you in a future video how to include other libraries in this same structure. But for now, let's just stick with CMake compatible libraries. So the first, what we're going to want to do is add external libraries, and this is very simple. It's the exact same way as we did here with our library. So inside here, we will add subdirectory external/glm and glfw. Now, I believe these are going to be case sensitive. I would just make sure they're case sensitive. So now that we've added these, what we're going to want to do is include them in our project. So this is very, very simple. If you're ever in doubt, the easiest way to look for it, usually it'll just be the package name. So in this case, it's a package name. We'll just add it, and I'll show you where you could figure it out if it wasn't working for some reason. So our public library is glm. So in the public sections, we'll just add glm. Done. Now, let's build this here. So you see that it's look for glm, it's building, It's building engine, building YouTube. That's good. Now, if we go back to our main.cpp, we should see now that we can include glm/glm.hpp. And just like that, our external library within our engine provided another library within here to our application. Now, you don't want to do that with everything. For example, most of the time you're going to want to abstract the Vulkan layer away from the application itself. So sometimes, but usually you'll want to avoid being able to do like Vulkan/Vulkan.h here, right? Usually you wouldn't want that. And for example, you usually don't want to give automatic access to GLFW. Usually you'll want to make them include that themselves. And that's what we're going to do. So we're going to do the same thing in here. So we'll go here. So in the private section, since we don't want them to have access to GLFW, we will put GLFW inside here. Now we will build that again. Now I use CLion. In CLion, this would have rebuilt everything pretty much automatically. Well, it would have come up with a rebuild required header and you would have clicked reload. But now if we go here, you'll see that we do not have access to GLFW. There's no GLFW headers in there. But if we go to our engine.cpp here, we have both access to GLFW stuff and we have access to GLM stuff. And that's how you would do that. Now, the caveat to this, so see here, this is an engine.cpp. If I took this GLFW header and I included it inside engine.h, you'll see that it doesn't have access. This is intended because remember that all of these includes inside here are accessible to your application layer. So anything inside here will not have access to anything private. This is all the public section here. The private section is inside here. So just remember that because that will happen sometimes. I'll show you inside this project. So inside my application layer here, you'll see that I have a few things. I have GLFW up here, and that's specifically because if you look at my library, and I'll just throw a shout out to the Cherno. I stole this bootstrapping code, the bootstrapping framework. I stole that from his game engine series. I found it very elegant. I liked it. And so you'll notice here inside our include platform, inside our entry point, that we create an application, and inside application we have includes to, I believe, the window. We have an include to the window, and within the window we have an include to GLFW. Because that include to GLFW is there, I had to make it in the public section. That's something I'm going to be fixing, or I intend to fix. I intend to put that back into its private layer. I actually intend to remove GLFW completely in the end, but for now I want to make GLFW private. But that's why that is there, is because there was a conflict and it just needed to be there to run. So just keep that in mind. So that is the basics of including a library, making it public and private. So the benefit to this is, let's say, like I did with my windowing layer, we'll do this really quickly because I don't want to get too deep into it. So let's say here we're going to make a platform. Let's just do platform for now, and we're going to make a window.h, and this is going to be our interface. So we're going to pragma once. We can do this quickly. Struct window. Let's make it class window, and we are going to say, let's just say yeah, so it's going to be void open window and void run. Oh, oops, of course. Virtual void run, virtual void open window. Yeah, that's good. That's what we're going to do. We're just going to do pull event and update. We are going to also create a service locator. So the Cherno did his service locating, service providing different things in a slightly different way, but I'm going to do it this way. So what we're going to do is service locator, class service locator. Now, if you're wondering where this pattern comes from, I will have a link to the book that I took this service locator pattern out of. It's game programming patterns. It's a very useful book. Anyways, let's keep this going. Public static inline const unique pointer window and get window return. We'll call this window. And then I need to. This is pragma once and include memory. Include YouTube engine platform window. Now this should give me window. What is this complaining about? Oh, right. So the issue we're having now is to do with the fact that this isn't actually being used. We'll continue doing it, but I'll show you what the issue is when we get to it. Why this is happening. The long story short, we've only included source.engine, and the other stuff isn't referenced anywhere. So we'll deal with that in a minute, because I believe that the compiler doesn't include anything that's not referenced directly from a CPP file unless you explicitly tell it to include it. So we could do like a file glob and get all of the H files inside here. I prefer to be explicit, and why have headers if I'm not going to use them? So this just forces that. Anyways, let's keep on doing this. We only need one more function now. We will do a static inline void provide window and this will be if window equal null pointer, we will return, and otherwise window equal unique pointer window from window. All right, so and finally we will have a private section here, and this will be again static inline standard unique pointer window equal null pointer. So this is our service locator. What this does is we can give it a window. So when we boot up our engine, we're going to give it a window and register it with our service locator, and then after we initialize our engine, we will be able to call our service locator to get the window and run the window functions. And just doing it really simple. So what we're going to do is we are going to create a new file here, which is going to be called platform.cpp, platform, not file, folder called platform, and we are going to call this glfw window.h and new file glfw window.cpp. Now again, we are going to pragma once. We are going to include YouTube engine /platform /window. That's not going to be found, but that's fine. Class glfw window public window. So what we're going to do is we are going to create a public. We're going to create a constructor. Can we delete the basic? No, I don't want to delete the basic constructor. Well, we're just going to do this. We're going to create a window, and we are going to we need open window and update. So again, we are going to void open window override. I believe you should probably put virtual here just to make it clear. And virtual void update override. So we are going to go here and we are going to include, another thing, we're going to end in a private section. Private, we are going to want a glfw window, which should be, give me a squiggle here, I would imagine. Number include glfw/glfw3. Right, again, this is the same issue as before. It's not linked in CMake yet, so there's issues. Anyways, we are going to glfw window, and I named it the same thing. Custom, we'll just call it custom window. Apparently, I put this in the wrong file. Yeah, I put this in the wrong file, and I wanted to put that there, but the pragma said here. Hopefully, I didn't confuse you too much. Anyways, so include glfw window, and we are going to want to implement these functions. So here we can just default constructor this, and for these ones here we are going to custom window. That's the name of it. Let's take this, take away virtual custom window, and then open window. So for open window, what we're going to do is glfw window, or first thing is we're going to glfw init, I think is what we need to do. And then let's keep it like this for now and get all the linking working. I think we've got all the linking working now. What we're going to want to do, we're going to include platform slash, I like to delineate, so anything inside the public section, I use the angle brackets. Anything inside the local section, I like to use the quotes. But I don't think it matters. So we do that, and now what we need to do is link everything together. So our app still only has the one file, so that's fine. What we're going to do here is we're going to make this automatic, so every time we add files, we don't need to worry about this anymore. So the way I like to do this is making a very inefficient. I'm told once the project gets really big, this is apparently inefficient to do because of the time it takes to do it. But we're going to do a file glob, sources, and we're going to add some stuff. We're going to do source.cpp. And then we're going to get all of the subdirectories of that and include the CPP files. And sometimes I play things extra safe. I don't usually go this deep, but sometimes you might. So you can add as many layers as you need. Source/star/star/star/star.cpp, and that's going to be more than enough. If you're ever this deep within a directory tree, you should probably seriously consider restructuring your directories. Anyways, and then here we place engine, which is sources. Now, if we build this, it should build everything okay. Engine.cpp, so there's a problem. So glfw window.h. So you see that these all work now. All right, so maybe a default constructor doesn't work for this. Like, I'm pretty sure it works for this, right? Oh, obviously, this is what I want to do, right? I don't know. Let's just do it manually. And then we'll go inside here and we will just create this constructor. And since we're in here anyway, equal, we'll just explicitly make this null pointer to be safe. Now let's try building that again, and you'll see everything builds properly. So now we will continue on with this. So now that we have all the linking done, we can do window equal glfw create window Now, we're going to do width. We're going to just do 800 by 600 for now. Title, we're going to say My Awesome Engine Window. And I believe that for this you can do null pointer, null, and null pointer. I believe you can do that. Let's close this preview window because we don't need it anymore. Okay, and we can put that back. So that should create the window. Yeah, so in our update, all we're going to do is glfw poll events. And if glfw window should close, and what we're going to do, so we're actually going to change this to a Boolean just to make it easier. And we need to go back to our interface, make this a Boolean, and make this one a Boolean. There we go. So now we will just return. So what this is going to do is it's going to return a Boolean. It's going to return false if window should close window. It's going to return false. It's going to return true if you click the X button. So with that done, we've got this should open the window and keep it open until you click the X button, at least in theory. Next thing we want to do is we're just going to call init here. We're going to call init. We're going to go back to our engine. We're going to change this to init. And then inside here, what we're going to want to do is, remember that service provider? So what we're going to do is we're going to create a, so we're going to do YouTube engine / service locator. All right. And again, this is in the public space. So let's add angle brackets and move it up. All right. So with the init, let's just say initializing window here. Initializing window. From here, what we're going to do is we're going to create our new window. So we're going to go service locator, provide. Now you see it's asking for a window, and you can overload this provide function to provide anything you want. So inside, first let's just finish doing this. There we go. So that's all you need to do. Again, custom window, new custom window, which adheres to the interface. So you can provide anything, any type you want, and overload this. What I do inside here, I'm still probably going to tweak it a bit. Inside service locator, you'll see I have a renderer, my window, and my input manager, and I actually allow it to provide an argument struct, any kind of argument struct here. But yeah, you can provide anything you want. You can even have it shut down services in a specific order. So if you know that, for example, your renderer depends on your window, you should shut down the renderer before you shut down the window. So this should be everything we need. So we've got our engine here, service locator provide, initializing window, glfw window here, glfw window here. And now finally in our application, we need to include our service provider. No, we don't even need to include our service provider. All we need to do is init. Oh, we do need to include our service provider. Sorry. So we initialize the engine. So now if we build and play this, let's just make sure it builds. So if we play this, you're going to see initializing window. So it went inside here, went to the engine and initialized the window. So now that the window's initialized, we have a window, or the engine is initialized, we have a window. What we want to do is include our service provider, YouTube engine / service locator, and then inside here we're going to do the service locator get window, open window. That will open our window, right? What is inaccessible? Did I? Right. So no window. Again, this defaults to private when it's a class. And yeah, it's public. Good. So now we go back here. This is good. We open the window and then we will while service locator. Now you could store a reference to this, but it's a unique pointer. So usually you'll just want to. I'm not 100% sure on the semantics. I think unique pointer would be fine because you'll get a copy of the pointer, I think, and then it would get destroyed in the scope. But I'm not entirely sure. You probably want to. Yeah, it's a constant reference, so you're getting a reference to the pointer, so you should be fine. Anyways, and then update. So while not update, because while it shouldn't close, then we should run. Now if I hit play, we'll build it again to make sure it works. We can hit just play, it would rebuild if I want to hit play, but I like being explicit. When you hit play, it should open the window. There we go. My awesome game engine window. You have a few lines of code, so you can give this engine to whoever you want and give them a windowing system. And there we go. And that's how you do it. And now if you hit X, it'll close. So that's everything that you need to know to create a C++ engine or library to provide to your main applications. And this allows you to modularize your code as much as you want. Yeah, so if there's anything you want to know, I'm likely to do a lot more deep dives within the C++ Vulkan rendering space. If you want to learn more about any of this stuff or any of the stuff I'm doing, let me know in a comment down below. And until next time, thanks for watching, stay tuned, and please subscribe. See you.